In our last video, we learned about the accelerations in circular motion. In today's session, we are going to solve some problems based on our learning. Before getting into the problems, let's recap whatever we have learned in the previous session. The first one is centripetal acceleration. Because of that acceleration, the circular motion is possible. Without centripetal acceleration, an object cannot move in circular path. So if there is a circular motion, that means there is a centripetal acceleration. Irrespective of the speed of rotation, even for constant speed of rotation, the centripetal acceleration is there because of the change in direction of motion. Or in other words, the change in velocity. The second acceleration is tangential acceleration. The second acceleration is tangential acceleration AT. This acceleration is because of change in speed. The change in speed of the object moving in circular path. The third acceleration is the net acceleration, which is the result of this tangential acceleration and centripetal acceleration. Centripetal acceleration is always directed toward the center of the circle, and the tangential acceleration is tangential to the circular path at any moment of time at a specific point. The resultant of these two accelerations can be found out by the addition of vectors. The next is angular acceleration alpha, which is the rate of change of angular velocity. Now let's go through the problems. The first problem is related to a coin which rests 25 cm from the center of a spinning disk. If the coin moves at a constant speed of 2.5 meter per second, what is the centripetal acceleration acting on the coin? So here is the disk. Disk is rotating in anti-clockwise direction, and there is a coin at a distance of 25 cm from the center. This coin is rotating in a circle of radius 25 cm. At any instant, the speed or velocity of this coin is along the tangent to that circle at that point, and this is given as a constant speed, 2.5 meter per second. The speed of different point on the disk is different. Depends on the distance of that point from the center of the disk. So here in this case, the centripetal acceleration AC is given by the tangential velocity square divided by the radius of circle. Here 2.5 square divided by 0.25 meters, which is equal to 25 meter per second square. The direction of the centripetal acceleration is always toward the center of the circle. Now let's move to the question number 2. If a toy car moving in a circular path of radius 2 meter at an angular velocity 1 revolution per second in anti-clockwise direction, then find following things. So let's see a circular path of radius 2 meter, and a car or toy car is moving in anti-clockwise direction. The radius of this circular path is 2 meter, and the velocity or the angular velocity omega is given by 1 revolution per second. 1 revolution is equal to the 2 pi radians. So 1 revolution is 2 pi radians, or it's equal to 360 degrees. So for numerical purpose, we convert the revolution per second in radians. So here the omega, the angular velocity, is equal to 2 pi radians per second, and pi value is 3.14. So it means this is 6.28 radians per second. Part B, the car's tangential speed. The tangential speed Vt is given by omega into r. Here the omega is 6.28 and r is the radius, which is 2 meters. So the tangential velocity is 12.56 meters per second. The part C is the centripetal acceleration working on the car. The centripetal acceleration is AC is given by omega square r. Here this is 6.28 into 6.28, which is omega square, and multiplied by 2, which is radius. And this is equal to 78.87 meter per second square. Section D. The car tangential acceleration. Tangential acceleration is the rate of change in magnitude of tangential velocity. Here, the magnitude of tangential velocity is constant. So, the tangential acceleration is equal to 0. The net acceleration is the result of centripetal acceleration and the tangential acceleration, and magnitude of net acceleration is given by AC square plus AT square. In this case, since AT is 0, so this is equal to the centripetal acceleration, which is nothing but 78.87 meter per second square, and the direction of this acceleration is in the direction of the centripetal acceleration, which is toward the center of the circle. So here is a question number 3. The angular velocity of an object moving in a circle of radius 5 meters is given by omega 0.5 t radians per second. So here omega is not constant, it's changing with time. So here is the path in which a object is moving. Its radius is 5 meters. Now we have information which is the angular velocity is 0.5 t radians per second and the radius r is equal to 5 meters. The average angular acceleration alpha is given by the change in angular velocity divided by the time duration. So here the angular velocity at 4 seconds is 0.5 into 4 and W1 is 0.5 into 2 at 2 seconds, and the time difference is 4 minus 2. So this is equal to 2 minus 1 divided by 2 equal to half radians per second square, and that is what the angular acceleration. The direction of angular acceleration is given by right hand thumb rule. Here the angular acceleration is 0.5 radians per second square. The angular velocity is in positive g direction because of anti-clockwise rotation. So the angular acceleration is also in the same direction, positive g. Since both angular acceleration and angular velocity is in same direction, that means the angular speed of the object keep on increasing with time. Now let's check the section B of this question. So angular acceleration at t is equal to 4 seconds. We saw average angular acceleration alpha is equal to 0.5 radians per second square. Now angular acceleration at a particular time. Angular acceleration alpha is given by the rate of change of angular velocity. This is equal to 0.5 t dt, which is 0.5 radians per second square. Here is a constant value. So the angular acceleration in this particular motion remain constant with time, which is equal to 0.5 radians per second. Okay. Now section C, the tangential speed at that moment, the time t is equal to 4 seconds. The tangential speed is given by the omega r. So omega is the function of time t. It means the magnitude of tangential velocity is also changing with time. And this is equal to 0.5 t into r, and r is 5 meter That means this is equal to 2.5 t meter per second. The magnitude of tangential velocity also changing with time. That means there is a tangential acceleration. So for time t is equal to 4 seconds, the Vt or V4 is equal to 2.5 into 4, which is equal to 10 meter per second. Now the tangential acceleration at t is equal to 4 seconds. Since the tangential speed is changing with time, that means there is a tangential acceleration. So for section D, the tangential acceleration at is equal to the rate of change of tangential speed with time, which is equal to time derivative of 2.5 t. And this is equal to 2.5 meter per second square. The magnitude of tangential acceleration is constant with time. This is in line with the constant angular acceleration. Now next is centripetal acceleration AC. AC is equal to V square by R or omega square R. And omega is 0.5 t. So that means this is equal to 0.5 t whole square multiplied by radius, which is 5 meter. So this is equal to 1.25 t square. That means the magnitude of centripetal acceleration is a function of a square of time. It means that is also changing with time in magnitude. So time t is equal to 4 seconds. The acceleration AC4 is equal to 1.525 multiplied 4 square means 16, and that is equal to 20 meter per second square. We already know that the tangential acceleration is 2.5 meter per second square. Acceleration A magnitude is given by AC square plus AT square, which is equal to 20 square plus 2.5 whole square under root. And the magnitude of this net acceleration is 20.15 meter per second square. So if we know the centripetal acceleration and tangential acceleration, we can find out the net acceleration. Now this is the magnitude of net acceleration. How we can find out the direction of this acceleration? Since tangential acceleration and centripetal acceleration is always at 90 degrees, the resultant of these two accelerations, the net acceleration A, is given by the vector sum of AT and AC. So here the direction of A, which is, if we consider, is making an angle with the centripetal acceleration, then tan theta can be written as AT upon AC. And in this case, this is 2.5 divided by 20. Okay, so theta is equal to tan inverse 1 by 8. Okay, now let's see fourth and final question or problem of this session. An object is rotating in an anti-clockwise direction on a circular path of radius 1 meter. So the radius is 1 meter and the motion is in anti-clockwise direction, that means in positive direction, with an angular acceleration alpha is minus 2 radians per second square. Here the negative direction shows that the acceleration, the angular acceleration, is in opposite to the angular motion. Now if object current angular speed, which is omega 1, is equal to 6 radians per second, then what will be its angular velocity, means omega 2, after 7 seconds, means time duration is equal to 7 seconds. Here the alpha is given by W2 minus change in angular velocity divided by change in time, which is t. And this can be written as minus 2 equal to omega 2 minus 6 divided by 7, or that means the omega 2 equal to minus 14 plus 6, that is equal to minus 8 radians per second. So here you see the angular velocity is in negative direction. Before 7 seconds it was rotating in anti-clockwise direction with positive value. After 7 seconds of time period, because of this negative acceleration, its current angular velocity is in negative direction. That means the object at this moment is moving in clockwise direction instead of anti-clockwise direction. And that happened because of this negative acceleration, the angular acceleration. Because of this negative angular acceleration, the angular velocity reduced from 6 to 0 and then start increasing in negative direction or clockwise direction. So understand the sign of the angular acceleration or angular velocity shows its direction. So if alpha and omega both are in same direction, both are positive or both are negative, that means the omega keep on increasing. But if alpha and w are in opposite directions, if in opposite directions, that means omega reducing, decreasing in value in positive direction. After some time it can be 0 and then it's start increasing in negative direction. So that's all for today's session. I hope you have enjoyed today's session, and if you think you have learned something new today, then please click like button and subscribe us for similar type of knowledgeable videos. Thank you for watching. See you next time. Bye.